meter or AMI possible. So we will be actually focusing on one of the newest technologies, and that is the NB-IoT, or Narrowband Internet of Things. So let's quickly go to the introductory slides. First, I would take up some clips from the newspaper. So, madam, let's go to the next slide, please. We'll try to quickly go through the slides because we have numerous slides here, and I'm trying to touch a whole variety of things for AMI. So this is the first introductory slide coming from the newspapers, 9th April 2021, so not too long back. And this talks about Tata Power's ability to bring out the NB-IoT smart meters in Delhi. So Tata Power is deploying the first NB-IoT smart meters. That is the constituent in Delhi is called Tata Power Delhi Distribution Limited, or TPDDL. Basically, it supplies electricity to North Delhi, and so they have been one of the first to take the credit for having NB-IoT based smart metering, and that's a wonderful thing to have, particularly when you talk about AMI. So how does AMI, which uses NB-IoT technology, how does that fare compared to the rest? And that's what we'll be looking at. So let's move to the next slide, please. Yeah, slide number 4. So Tata Power basically has this NB-IoT set up with the services of the Reliance Jio network. So with the initiative, Tata Power Delhi Distribution basically is the forefront of technology. These are points which I've taken from that news clip. So obviously it is going to be talking about Tata Power's ability to bring out new technologies. So you can keep that aside, but let's look only at the technology aspects. We'll look at NB-IoT. Basically, what is NB-IoT? It's a low power, wide area network radio technology. So radio technology means it's a wireless technology. Basically, it's a standard developed by 3GPP, which is a standards organization, and it enables a wide range of cellular devices and services on this NB-IoT technology. So they have deployed about 230,000 smart meters with this RF technology, and it's the first such kind of technology integration, where what they have done is Tata Power has roped in some meter manufacturers on one side, and they have taken the services of Reliance Jio for their network, and that's how they made this NB-IoT service of the Reliance Jio possible. So let's go to the next slide, please. Slide 5.
Yes, sir.
Yeah. So in the NB-IoT basically it's a new and cost-effective technology in 4G and 5G spectrum, and with this technology, the interference and obstruction basically which arises in public network generally, we talk about congestion in public network. This will no longer be hampering the performance of smart meters anymore. Earlier, we were at the mercy of the network. If the network was congested, we had problems in connecting to the meters, and this is because two separate entities used to be there. The communication network, essentially managed by the telecom people, and the meters, which were they belonging to the electric utilities. So here, for the first time, we are having a combination of both the the meter as well as the communication being handled by a single electrical entity with Tata Power. Of course, the services of Reliance Jio is taken, but that service is not getting hampered due to the congestion of the public network. So this is not a public network which is going to decide on the ability to connect. So there's no congestion. So NB-IoT basically is a new technology that's both the 4G and 5G compatible. So we are talking about technology that is and it offers a dedicated channel for smart metering. So there's no reduction in performance from interference or obstruction due to congestion of public network. So let's move to the next slide. So Tata Power basically has taken the matter of remote meter readings issue, because that during the pandemic times, the safety of consumers is of prime most importance. So they have ensured that the number of remote meter readings can be increased without getting into the safety of consumers issue. So and this is very important in the due to the current pandemic issues that we are having. The introduction of this NB-IoT is revolutionizing technology. That's what Ganesh Srinivasan of Tata Power DDL mentions, and this is because he believes that this unique technology integration will not only strengthen the credentials of the utility, make it a utility of the future, but take the Indian meter program to the next level. Why is this so important, so particularly important? Is because India has been trying this issue of smart metering, taking this up at different levels for not just years, but I would say more than a decade or 2 decades. This thing has been on the cards, but it has failed miserably. Actually, the entire world so far has already completed their smart metering programs, and we are just at the juncture where we are entering the smart metering program. One way it has been a boon to us in disguise, because if you enter late, you get the latest technologies. So we are able to have our smart metering done using the latest state of the art concepts and with NB-IoT, which the other countries have failed to do because their implementation of smart metering far preceded us. That means they already had the smart metering in place 5 to 10 years back. So, but we are at this major juncture where we need to see that our country moves from the system that we are currently in to the smart arena or the smart network. So let's see how we can achieve that. So we go to the next slide, please. So Tata Power basically has shown us the way. It is important because all other utilities, all other states in our country, we are struggling at the moment. So what I am trying to highlight through these initial introductory slides is that it's not a piece of cake. It can be just simply cut and eaten, and we get this technology. It's not that simple. It has We will have to work towards that in converting the old technologies, because we have so many different types of technologies in our metering at the moment. We have the old-fashioned, electromechanical meters, the Ferrari meters still in place. We have the static meters, which are not so intelligent. We have some smart meters, but with other technologies. We have some smart meters with DLMS, and so on and so forth. So there's a wide variety of meters in place in our system, and we need to now bring rope all of them into this so-called smart metering network. So how can we achieve that? That's where Tata Power has shown the way, because they have taken this of numbers which are in lakhs. That means the 2.3 lakhs is what they have taken. It's not a small figure. So that means that definitely Tata Power has shown a workable solution. It's not just a pilot may be in few thousands, and they show that it's working, but when they escalate that and deploy in larger numbers, it becomes a failure. So that's what our country has seen so far, and that's the reason this particular technology assumes prominence. We are at a juncture in the year 2021. What's important is a technology that can really help India take it to the next level. So let's move to the next slide, please. So what's important is that we need to have according to this January 2021 report in the Indian press, it had conducted these pilots with several electricity distribution companies, and it found that this is the way that we can move ahead and get NB-IoT in place. So, but Tata Power is just one small entity. It's having a population of just 7 million in North West Delhi. So just Tata Power's implementation of NB-IoT doesn't mean much. We need to see that bigger states, whether you can say Uttar Pradesh or Bihar, where we are having big problems in the metering sector, whether they will be successful in making this whole technology a success. So we move further to the next slide. So our national metering program, basically it envisions the installation of 250 million smart meters, right? So 250 million is not a small figure. That means 250 to 10 raised to 6 is a figure which, if you would like to complete this program in, say, 3 to 4 years, that means you can just imagine the number of meters per annum that we need to prepare ourselves with. So it is not it's a small thing, okay? But because this has been shown to be viable, I believe that this is the only technology that can really, make it successful in larger states like Uttar Pradesh, New Delhi, etc. So far means over the past 1.5 decades I'm talking about. Okay, it's not just a few months. So over so many decades we have been struggling to get into smart metering, and still the total sum number of meters that we have is just 1.3 smart meters. That's less than 1% of the entire number of smart meters that we need to have in our country. So because this NB-IoT comes in this backdrop of world's largest electricity smart metering program and underway, so it's aimed at cutting the distribution losses and getting and basically strengthening the whole distribution sector. So how will we be able to do it? That will basically look at more details in this particular presentation. So as I said again, let's understand the magnitude of the problem. The magnitude is sheer numbers. I can tell you this because as a meter manufacturing company, Baroda Electric Meters, it had been supplying energy meters since 1961. For the past decade and a half, we have been having issues because of all these problems related to technologies, etc. Right now, most of the utilities have got their house in order. So it would be the right time for Baroda Meters also to continue its production and see that we also join in the smart metering program and supply, as per the technologies required by the utilities. But that's when the utilities say, give a green signal and say that, yes, we are ready for, say, NB-IoT based technology. That's the time, we can take that move. Because, we are an industry, we are a manufacturing entity. So we cannot run into further losses. In fact, our, always our curve has been 2 years of loss, 2 years of profit and loss and profit, in a cyclic manner. That's how, our industry has been having since 1961. So we decided that right now, till the utilities stabilize, we will not enter the metering game. Instead, we decided that we'll divert ourselves to something which is close to metering. And that's how we, chose to be in the IoT sector. So, and that's why my interest is more on the NB-IoT. The second reason is that the country has moved, in fact, the whole world has moved to the IoT revolution, it's going through the IoT revolution. And having said that, I think we can change the slide to the next one. I would speak more on the smart metering and the smart grid, right? So, so in electricity and as electrical engineers, we have been looking at, concepts like smart meters and smart grids, etc. But the world has not been sleeping over these past 2 decades. The world has been moving, simultaneously, and what the world has realized is that, just as, electrical sector needs a smart version, the rest of the sectors also need smart devices, and the only way that could be achieved is with the Internet of Things. So that's why the whole world has now entered a phase, what we call as the IoT revolution or the Internet of Things revolution. So whatever we are seeing here as this slide, it's talking about what you see is in graphical form. 2 sides you have all the things what we have written up from the top to bottom, and that's what is the smart grid vision. All right, whether you talk about hydro, small hydros, or you talk about HVDC links or residential CHP and so on and so forth, all this has been made possible thanks to the smart grid vision. But as I said, the smart grid vision has been going on for more than a decade now, and in the same period, what has happened is the IT discipline and the computer discipline has made further strides and has taken us leaps and bounds to the IoT age. So smart grid now comes under the umbrella of IoT. So it's no longer looked upon as a smart grid vision. It's more about IoT vision, because as I said, the bigger umbrella is IoT. Smart grid occupies a section of this umbrella, which is the IoT. So revolutions don't happen, just with simple triggers, or it doesn't happen at just one remote location. It engulfs the whole, planet. So the entire, globally, basically, we see that we are in the midst of this so-called IoT revolution. So let us look at this IoT revolution. But before that, let me quickly, take you through what was considered as smart metering over the past decade in India. So we are taking the next section, which is smart metering. Let's quickly go to the next slide, please. So this is just a cartoon, talking about the role of smart metering. What is smart metering? So everyone, perceived it. Even the giants in energy metering, they perceived smart metering in different ways through their own, perception. They would look at smart metering. A firm like Cisco would, relate it to their routers and other, devices that they have. General Electric would look at it in their terms. So also every organization would be looking at it in their own way. So this particular cartoon basically is, talking about how, if this particular boy is, being reminded that how many times must I tell you to turn off the bathroom light. So right now, in the IoT age, in the smart metering age, this is all not relevant anymore, because it's the devices which are going to talk to each other and take care of it. If this boy is, coming down the staircase, the bathroom, light would be shutting down on its own, considering that there's no occupancy in the bathroom anymore. So this is the, the essence of this particular cartoon. Let's move to the next slide, please. So so basically, who are the stakeholders when you talk about smart metering? We're talking about, linking up everyone. The government on the top, they control the regulations, they control the CO2 emissions, the energy consumptions, etc. So they are, of course, interested in smart metering. You find that on the left side, you are having, the various utilities, whether it's EDF, whether it is state grid, whether it's PG, PGCIL, or whether you're talking about NTPC, and on the other side, we have the consumers, of course, that consumers at large who would like to benefit from this energy awareness program and who can adapt and save, on the electricity bills by choosing wisely. So they're all the stakeholders, means it involves everyone, the government, the consumers, and the utilities at large. So let's move to the next slide. So what it means to all these different categories, when you talk about market drivers, the smart metering basically proposition to the utilities is, it means cost savings by efficient remote reading and billing. It talks about better peak load management. You have new tariff models. I think you must be aware that we had in Gujarat new tariff based on kVH, or kilovolt ampere hour. So that kind of tariffs can be brought in at ease. You have better protection against tampering. So even if someone tampers, we should be able to detect the exact location of the tamper, thanks to smart metering. So far, this tampering used to be a big issue for the utilities. In fact, a lot of revenue was getting lost from the utilities because of meter tampers. Of course, it was done in connivance with the meter readers themselves. Once upon a time, when the meters were not so smart and when they were electromechanical in nature, like I mentioned earlier, the Ferrari meters, they could be easily tampered. These days, the static meters are not so easy to tamper, but still, if someone bypasses a static meter, then it goes undetected in the present age. But if you have a smart meter, then even if someone tries to tamper the feed line from the utilities, then also such a tamper can get easily detected. That's because we have smart metering as an extensive program. All the meters would be smart, and they would be able to talk with each other and find out and carry out real-time audit and find out where the exact location of the fault is. Fault means tamper in our case here. So as far as consumers are concerned, the smart metering program basically it's a value proposition for them too, because when you have more accurate metering, the consumers are happy that they're not getting billed for someone else's consumption, like the neighbor's consumption, etc. Because of frequent billing, they'll be able to ensure that they pay their bills on time. If the billing is done on a 2-monthly basis, bi-monthly basis, then of course the consumer has more difficulty in paying those bills at the end of 2 months. But if it's more frequently billed, then it becomes easier for the consumer to pay a smaller amount more frequently. Cost reduction basically by better insight into the consumption, because now the consumption is visible right from the mobiles. Consumers know what exactly the consumption is. The ability to switch significant consumption to less expensive hours, that because we are going to have something called time of day metering, etc. So in the smart metering regime, because of cheaper power at odd times, consumers can shift their load or their consumption to those hours. And for the government, it's also a value proposition, because the CO2 emission basically reduction takes place, and we have an increased awareness of energy consumption pattern. So getting all the utilities and the basically the producers of electricity as well as the consumers of electricity, they can be easily matched, and consumer and the government can save a lot more. So that is a value proposition. These are the market drivers, and that's why we are looking at smart metering. Okay, so it is not that it's only an enabler for one or two entities. It's basically an enabler for the entire population. So 10 years back, we entered into smart meters. We took up this, just taking this as an example, how we started off with smart metering. There was one energy metering chip called EM773 from NXP Semiconductors. It was an ARM Cortex M0 based chip, which we decided to take because it far better than going for an 8-bit or 16-bit processor. They were 16-bit or 8-bit is okay for simple applications, but for a smart application, it's better to have something like a 32-bit more powerful chip. So this EM773 was a dedicated chip offered by NXP Semiconductors based on this ARM Cortex M0, and essentially they had software code also included with that chip. It was nothing but the hardware was just ARM Cortex M0, but on that hardware they also ported software which essentially does all the computations for energy metering. That's why EM stands for energy metering chip. So this chip was brought out by the utilities. In fact, next slide, please. Next slide. Yes, so that's the EM773 ARM Cortex M0 chip. Basically, let's go to the next slide. So what we did was we took that chip and we clubbed it with the OL2381, because EM773 essentially was a microcontroller or a 32-bit ARM controller, which essentially does the computation work. But what about communication? We needed wireless communication for smart metering. Can be achieved with two main C's. One is computation and second C is communication. So along with both these C's, both have an equal role to play in making the meter smart. So here we used a chip called OL2381, which was NXP's chip for wireless communication, and that was compliant with the wireless M bus. So that was a technology that we used for making this particular meter smart. It was called as plug meter. In fact, I'll show you some images of this plug meter in the next slide. So we can go to the next slide. Yeah, this is how it used to look those days when it was offered for the initial pilot tests, etc. So this is the outer view on the left side, and on the right side what we see is the NXP's smart plug opened up. So when you open it up, you can see all the components inside. What you essentially see are the major components, the bigger components, which are nothing but the capacitors, etc. Of course, there is orange cubical stuff here, which is nothing but a relay. So this is a new component which is not there in the traditional energy meters. In smart meters, we have this relay or a cutoff device also included. So this is a major change which has come in, that you not only are able to read a smart meter, but you are also able to control a smart meter. So it is both the things can be done with a smart meter, and this becomes very convenient. In case of any faults, we can disconnect a particular section or a particular consumer. If the consumer is defaulting and is not been paying their bills regularly on time, then the consumer can be disconnected. Or if the consumer is overloading the line at a time when he is not supposed to draw power, let's say only essential utilities are or essential appliances are to be supplied at at times when there is there is excess load and we want to lower down the load, or we want to chip off the peaks in the load curve. That time, if the consumer is using excessive power, then this relay can be used to disconnect the consumer also. So this is how we look at the smart meters from inside. Okay, this was even before the NB-IoT. Okay, as I told you, it's a wireless M-bus, and this had a range of a few hundred meters, not more than 100 meters or 200 meters. So it was okay for connecting different meters within the same establishment. That means it can be used essentially for sub-metering, etc. Of course, there were other technologies also. We had the wireless, technology. We had the PLCC technology. We had the GSM technology. We had all these technologies, which can be used for connecting or communicating between the meters, and also between the meters and the substation. So let's go to the next slide. That's also a pictorial slide which talks about how these smart meters they connect through the wireless M-bus. So these are the so-called plug meters. Essentially, they are plug meters because it looks like a plug. So you can plug any appliance onto this plug, right? And whichever appliance you plugging on, that appliance is going to be metered and be going to the central M-bus USB adapter, which collects all this information from these different meters and picks it up and displays it on the PC. This was just as I said, set up for pilot testings, etc. It was not for field testing in a big way. This is the technology which was brought in about 15 years back. Okay, so that's the time when the smart meters essentially was there, and the term AMI also came to be used essentially to differentiate from AMR, because earlier, before this kind of wireless M-bus and other smart technologies came in, we had a phase where the meter readers had to go and pick up the readings using meter reading instruments. That's MRI. Okay, so that was the to differentiate between that phase. Because people were considering that to be smart. That's not smart any longer, or in fact, it was not considered smart about 10 years back even, because the AMI was considered to be much smarter and was serving the needs of the utilities and the consumers at large. So this is a glimpse what I'm giving you of the smart meters that were in use a decade back. Okay, why I'm taking you back through history is because you need to understand what is there with us right now, because even this technology is not available with us in our country. None of the smart meters has been successful. As I said, we have only 1% of the entire country moving to the smart regime. So essentially, that's because the utilities as well as the consumers have not accepted the smart technologies so far. That's the reason so much of pressure on the need for NB-IoT. Okay, so we'll be coming to that shortly. Let me close this EM773 slides with a few more slides following that. So essentially, what exactly is a smart meter then? It's a computation cum communication device. Okay, so this particular appliance, let's go to the next slide, please. This particular smart plug, I call it the VH smart plug because we also have ampere hour, or volt ampere hour, which is nothing but a unit of apparent energy, right? And that's something which is also possible using this EM773. So decade and a half earlier, as I told you, we really launched into apparent energy metering and try to make that possible, because all this, whatever you see, these formulas, where we talk about voltage, the voltage would be measured and calculated as an RMS value. Current would be calculated as an RMS value. The VA would be nothing but the voltage into the current, both RMS. So we would be getting the true values of voltage, current, apparent power, and so on. And that's what made it very interesting, because we would get the true value of power factor for the first time, because the current meters, what you have in the consumer's premises today, if you go anywhere in Gujarat or anywhere in our country, in India, we'll find that the power factor is is calculated based on the fundamental and not the higher harmonics. These days, higher harmonics play a very important role, and and we need to control that higher harmonics. We need to see that we try to minimize the higher harmonics, and the effective way to do that is by using concepts like apparent energy for tariffs, which records the true VA and the true power factor. All right, so We can move to the next slide, please. Yeah, here we are giving the the definition of the and I think this slide, yeah, we give the definition for this apparent power. So S is nothing but apparent power, which is Vrms into Irms. We have the active power, which is nothing but the integration of Vi dt, and at the same time we also have the non-active power. But non-active power, you can see here, is taken as a square root of S squared minus P squared, which is nothing but the square of the apparent power minus the square of the active power. So this is how it is, and the power factor is P divided by S, and this would give us the true power factor. Okay, and the current meters are not calculating power factor with this formula. It's a very simple formula, but as I said, unfortunately, this IEEE standard 14592010, you can see that it's 2010 or more than a decade back, right? This standard was available, and yet meter manufacturers having difficulty in calculating the true power factor and showing that to the consumers. So we move to the next slide. I'll just show you a couple more figures which show the figures of voltage, current, and power factor. Let us move to we can skip this slide. We can move to the next slide. I think we've gone back. We have to move further. That is, yeah, we keep going further. Yeah, total harmonic distortion THDI is important because the current waveform these days, if you see, they're highly distorted, and it is important that we keep a control of the harmonic distortion, because ultimately any harmonics which are injected not only affects the consumer who generating it, but it could also damage the appliances of his neighbor, who's in which the harmonics could be entering and damaging, say, the capacitors and other electrical appliances, delicate appliances which the neighbor might be having. So harmonics is really harmful. We should try to eliminate or minimize this THD. Okay, so that's why I've indicated these formulas here. All these formulas, it's child stuff for the energy metering chip. In fact, as I said, the NXP had offered all these parameters free of cost in this ARM Cortex chip. Okay, so that was simple for them because all this competition was not such a big challenge for the ARM Cortex, which was quite a powerful chip. Let's move to the table on the next slide. Yes, here we're showing some of the appliances that are connected to these smart meters, and here you can see on the right how you have the voltage recorded at each of these appliances, whether it's a LED lamp, whether it's a personal computer, microwave oven, heater, etc. Well, the amount of current that it is taking, the amount of power we see here. But of course, what is not visible in this particular table is the more interesting parameters, which is the S and the THD, as well as the because THD and S, when compared with this P, when you have P divided by S, we'll get the actual power factor. So the true power factor also is calculatable. We can calculate that and understand how good or how bad our appliances are. Right now, most of us, whether we are a common layman or whether we are an electrical engineer, we have difficulty in understanding at what power factor these appliances are working, whether it's a laptop, whether it's a microwave oven, you name it. That's because we are not having those meters recording the true power factor. They are only recording the power factor based on the fundamental and not the other harmonics. Okay, so harmonics plays a very important role here. So let's move to the next slide, please. Yes, this one gives a comprehensive picture of that smart metering output. Here we can see very clearly on the right hand side we have PF and PF1. Can you see PF1 is basically the power factor that most of the meters today in India, they're recording and they're displaying. So it would have displayed 0.97, right, for this particular appliance, whatever the appliance may be. It is connected to the plug meter 1, and this plug meter 1 is recording all these voltages, current, active power, the apparent power, etc. So you can see that the active power is 37, the apparent power is 63. So power factor is nothing but 0.58. So and it's far different because 0.5 is different from 0.97. 0.97 is practically unity. So you might be on one hand happy that it is unity power factor, but actually the power factor is 0.5, right? So it could be so drastically different, and that's why I thought I should present this slide to tell you what these are some of the secrets which smart meters can reveal very conveniently, because they are generally otherwise hidden. Even though those parameters are available, they would be placed in the back and would not be brought out onto the display in the present metering systems. All right, but if it would have, then it would have been really shocking, both for the consumers at large as well as the electric utility personnel, as well as us, electrical engineers, that there's such a big difference between the power factor and the fundamental power factor of PF1. Nevertheless, it's our duty, as electrical engineers, particularly from the academia, that to see that we bring out this power factor PF, as early as possible, and that's what was one of the missions of Baroda Electric Meters Limited in Center for Apparent Energy Research. We tried to do this, and we brought out some pilot projects, particularly in industrial townships such as Nandesari. In Baroda, there is a small township, GIDC township called Nandesari, and in that township we had all the street lighting lamps converted from the old lamps to the LED lamps, which are dimmable as well as smart, and they are working at unity power factor. So in the process we got PF to be increased from 0.5 to approximately 0.95 or 0.99. So that's the power of knowledge and information. If you have the information with you, you can derive the necessary knowledge to correct the problems. All right. So on this note, shall we close this chapter on the old technologies that we have had over the past decade? So any questions we would like to pose at this stage probably can be posed right now. Of course, Madam said that we could have all the questions at the end also, but I believe that when the information is fresh, it would be easier for me to take you all back to the appropriate slides and answer them. So should I take some questions at this stage? Yes, just a couple of them.
Yes. So participants, if they are having any questions, you can unmute yourself and ask.
Because 2 hours is quite a long session. So if we have a short break and we have a question answer session, probably everyone would sit up and will be freshened up with this active participation on both sides.
Hello.
Yes.
Good morning, sir. Yeah.
Good morning.
This is Ketul Patel from Gandhi College, Surat. Actually, sir, you said this actual PF is around 0.5, right? So
Yes.
wasn't it affecting the billing and wasn't it apparently visible in the billing when because they would be billing according to power factor of 0.1 and the reactive power delivery would be much higher than that. So wasn't it apparent to the utilities at that point of time?
Very good question, Ketan. I am really happy that Ketul, sorry, I'm happy that you brought this point forth, because it is really interesting to see this, that both the utilities as well as the consumers are ignorant about this fact that the power factor is so low, and because in the billing system they're not able to catch it. Why they are not able to catch it is because the entire billing system is based on that bad system, the old fashioned system, where power factor shows up as unity. So they are not worried about the apparent power. And again, apparent power, if those meters calculate, how they calculate the apparent power? They calculate it from the active power. Active power is perfect because active power is something which cannot that power cannot be created or destroyed or whatever. So it very truly represents P. P is going to be 37 here, and in the utilities case also P is going to be 37. Okay, because that's not going to change. What is changing otherwise is the Q and S. What the present meters do is they calculate Q, and when they calculate Q, Q means the reactive part, they are calculating Q not with the higher harmonics. They are just simply calculating Q, that means Q1. All right. So because they're calculating Q1 and they're taking P and Q1, you're going to get S1 and not S. So what they are seeing as the apparent power is not the actual apparent power. It's not coming from the fundamentals of RMS values of voltage and RMS values of current. In fact, that's why I fought on this note, quite a bit, right at the center with the Central Electricity Authority. I'm taking you back 20 years, okay, because my initial fight on this was about 20 years back. Then I took it with the GERC, that's Gujarat Electric Regulatory Commission. I fought at that point. In fact, I was in the high-level expert committee set up by Ministry of Power. So I was there, and I was in a position to influence people there myself. But I did not want to take that that step in that manner. I wanted an expert committee to really take it up and evaluate it threadbare and understand that it should be made possible. In fact, there were directives right from the Ministry of Power, right from the state government to GEB, the erstwhile GEB. Right now we have MGVCL and other Dakshin Gujarat Wej Company, etc. But those days we had one monolithic kind of Gujarat Electricity Board. So we took it up with GEB, but GEB did not like GERC, dictating terms to it. Nevertheless, we got an order in our favor, order in the sense that apparent energy should be apparent energy metering should be worked out as a pilot, and that was eventually implemented in 2010. And we got this tariff for street lighting segment, which was based on apparent energy. And that's the very first time, that was the eye opener for everyone, that S is different from S1. That means S can be significantly higher than S. So far, only what they used to see was S and not, S1 and not S. So thank you, Ketul, for bringing it out. But yes, very much true that people were not aware that the power factor is so low, nor that there was so much of harmonics being injected into the system, or whether due to any other this power factor can be low because of both harmonics as well as inductive loads. So all that should be considered together. So the technologies which were in place, we are not able to distinguish that, and we're not able to put
interesting. Thank you, sir. Yeah.
Thank you. Thank you, Ketu. Good. So I think we could move further then. So let me take you to the next phase of this session. If there's any more question further, you can please ask me along the way, but I think we'll go further from this point. So my objective is now to take you to IoT. That is, in order to understand NB-IoT, we need to know about IoT. So I'll just take you through the introduction of IoT. I'll take about 15 minutes from the IoT. So let's skip to slide number 27, please. Good. So this is the Internet of Things. So what does this really mean? A few more clicks would give us the I would say the bullet points on the left-hand side. So let us quickly look at what this graph is and how it should be interpreted. We are talking about revolutions here, and we have 3 different revolutions. Actually, as I said, a few more clicks on this slide would give us those bullet points. So let me take the first bullet point. That's the internet revolution. Okay, that happened more than 2 decades back. That is from the 1990s. Basically, what it did was revolutionize how people communicate and work together. It was an era of free information for all, which transformed life. Only in the last decade, we have been able to see the revolution of the internet really kicking in hard in India. Actually, 2 decades back itself, it had set in other countries. So the next wave of internet was not about people, but about intelligent devices. So we had another revolution after that, and that was you can see this inflection points in the graph. First one is in orange. That's the first one, which talks about the global connectivity, where you talk about 1 billion sites, websites. That's all thanks to the internet. Then you have this blue graph. The blue graph, you can see there's an inflection point or the slope has changed. This blue graph talks about not sites, it talks about the people. and we are having 5 times more people than the sites. So we have 5 billion people who are all linked with the second revolution, and that's the next wave of the internet. This revolution was not about people but about intelligent connected devices. A few more clicks on this slide would give us the more bullet points, please. Yes, a few more. Yeah, so it's not about people but about intelligent connected devices. Then the last one is to see that we successfully connect with the real world. So the devices must work together with speed, scales, and capabilities far beyond what people need or use. So this inflection point, what you see in blue, was to do with mobile devices. So we had 5 billion people, so each one carrying a mobile in his pocket. So that was what represent the second revolution, the mobile revolution. So from the internet revolution, we moved to the mobile revolution. And today we are in the third revolution, and that's the revolution of IoT devices. So what you see on the top, there are all these different types of machines here. You can see some washing machines, you can see some, some gaming machines and refrigerators and whatnot. So all these different types of devices, cars also, of course, included. So all of them, all these things, so-called things, which we consider to be normally to be very dumb, whether it's the sofa or seat or chair that you're sitting on, whether it is the TV that you're watching, whether whatever, whether it's your own the clothes that you're wearing, you might consider that what has clothes got to do with IoT. Clothes has a lot to do with IoT, because if you wearing a cloth which has to be washed in a washing machine, the washing machine needs to know what kind of clothes you are actually washing, and choose a kind of a cycle which is either gentle or strong, so that the cloth does not get destroyed or damaged, right? So that's why the IoT revolution is the one which is the most important right now, and the most challenging of all, because we're talking about far more number of things than people. We're talking about 50 billion things compared to 5 billion people. So if you're talking about a mobile revolution, was such a big revolution because of the number of mobile that have to be manufactured to cater to this revolution. Well, the IoT revolution is far bigger and far more challenging. So we are in this IoT revolution. So I hope that you're able to appreciate that why we are talking about this particular AMI, or advanced metering infrastructure, under the banner of IoT, because IoT engulfs every other technology within it. And essentially the revolution, if you would like to say, in 2021, what is the revolution that we are under? It is the IoT revolution. There's no other second name for it. Okay, so that's the IoT revolution. Whether you are a doctor, whether you're an engineer, whether you are a common person on the road, anyone, and everyone, it's going to affect. So that's the IoT revolution. So let's go to the next slide, please. So this again summarizes what we just said. Internet, it connects the websites and workstations. The mobile revolution, we're talking about handsets for 5 billion people. And then we're talking about 50 billion smart devices. This is the third revolution that we're talking about. And look at the slope. Why is the slope important? Because on the x-axis, we have the time graph, right? So in the time graph, you can see that the way it's going up exponentially upwards. That speaks volumes of the challenge that we need to face, because it's getting in front of our eyes. We are seeing that the whole world is changing. Okay, this is what we call as disruptive technology, something that disrupts everything what is there. Whatever we are holding something today in our hands, that is useless. It becomes scrap, because we are having a much smarter device that we can hold on to tomorrow. Okay, so that is a disruptive technology. All the older technologies, they just go into the dustbin, and this one rules. This one takes over. Okay, so that is the technology that we're talking about. And smart metering very much comes under the IoT revolution. So let's go further. I'll just take a few more slides on this. I don't want to touch more on this, because I want to take up NB-IoT, which is part of the IoT. Okay, so where are all these devices? Which you're talking about, the smart devices, the IoT devices? It is there everywhere. You own so many of them. In cars, you have more than 100 such processors. The smart devices, they pervade industrial sectors, industries, hospitals, houses, transportation. You name it, it's there everywhere. Okay, a few years back, I could not have said all this because we can say that India is still developing. We're still getting these different processes. We're not a semiconductor manufacturer in India, so we have to borrow all the silicon chips from outside. So all these the challenges were there in front of us. But today, kind of ironed out this. We have taken it in our stride that we are not going to be manufacturing silicon anymore, but we'll be working with IoT device in big way. In Baroda meters, as I said, we stopped manufacturing meters for a short while. So what did we do? What we did was we decided to go in for such smart switches like this, whatever I'm holding in my hand. This is a Wi-Fi smart switch. It comes from the Sonoff family of that. This manufacturer is a Chinese manufacturer, of course. And as I said, in India we don't have silicon, so obviously we are at a disadvantage when it comes to manufacturing electronic devices. But it doesn't matter. We need to go much beyond that. We can talk about software and other things that we could be working with. So this switch is nothing but an IoT switch, and this IoT switch essentially takes the input from the utility mains, and the output is given to the appliance that we would like to control. Inside it is the relay that we can control from a mobile using the apps such as this is a Sonoff switch, so they have an app called a EV Link app. So if I take that app and if I control switch this on or switch this off, I can do that even locally, that is within the place where the Wi-Fi router is placed, or I could go remotely to a different place. If I'm having internet on my mobile, I should be able to control that wherever I am in any part of the world. So this is the starting point of Sonoff. Probably they started manufacturing this in big volumes about 10-15 years back. But now they have come to and everyone has entered that arena. This is one more switch of theirs. It's a Sonoff power. So why I thought that I should display this Sonoff power is because it's very much relevant to the theme that we are right now looking at, and that is the smart metering. So this is nothing but a smart meter. All right. So it's a smart meter which the consumers can buy from the market and install it wherever and whichever room a consumer would like to meter the appliances and or his load. So this device offers all these readings, whether it's a voltage, whether it's a current, whether it is power. So all the parameters are given. A beautiful load curve is also displayed on the screen, because once you have this information out to another computing device such as the mobile, we should be able to process any information that such smart devices can offer. So that is the beauty of networked devices. And this all this happens in the background. You don't need to press any button to really say that, okay, now you compute the power, or now you show me the load, or calculate the graph, or draw out the graph for me, or whatever. So that's all there happening in the background of the devices. So they're all competing with each other. I'm computing the values. They're all taking the values from each other and building up the knowledge that we would like to have on these systems. So as I say in this slide, today the systems are weakly connected, but that will quickly change. All these slides are often definitely old and a bit outdated. Okay, because this one was a slide which I had made for IoT applications in industry about 2 years back. In this 2 years itself, we can't say that the systems are weakly connected anymore. All that has changed. It is quite strongly connected. Okay, and IoT will do fundamental things. It is doing fundamental things, right? So will means in the future tense. But as I said, this slide is old, and even in this 2 years, I've shown you earlier the graph, which was exponential, right? It was rising up exponentially. So we have come in year 2021. We can see that fundamentally IoT has been doing things differently, and that it is a kind of a technology that is really, I would say, disrupting other technologies. All right. So that's why it's called disruptive technology. So let's move further, please, to the next slide. So I think what I'll do is we'll skip all the slides. In fact, this presentation I have shared it with Madam, and you all can take access to this slides. What I would request is that you all take a look at all the remaining slides which I skip here, because they are related to the IoT and the IoT revolution. Of course, that is the precursor to NB-IoT, and the AMI, which we are looking at. But it is a very vast topic. IoT is a very vast topic. So I will not, other than just to invoke your interest in IoT, I thought that we should have a few slides here. But the other slides, though they are relevant, we will skip it and move over to say slide number 36, where we'll talk about the definition and structure of IoT. I think even that we'll just skip. I think we'll move directly to because this whole IoT section I would like to skip over so that we make way for or make time for so slide number 64 I think is enabling technology for IoT. So we'll just look at some of the enablers for the IoT technology. So slide number 64, we'll move to slide number 64. Yeah, so the enabling technologies for the IoT. So what are the enabling technologies? Because that's what we are interested in as engineers. Our role is to identify the technologies and use the technologies, and the rest of it, can be handled by the layman. Okay, so let us look at the enabling technologies. There are many technologies that enable the IoT. Key foundation piece is the network used to communicate between the nodes of the IoT installation, a role that several wireless and or wired technologies may fulfill. So it doesn't mean IoT does not mean that it should be wired, okay, or wireless. It can be both. It can be either some wireless nodes and some which are wired nodes. All right. So the first one, which is pointed out here, is the RFID or near field communication. In the year 2000 and later, RFID was a dominant technology. Later on, NFC, okay, near field communication became dominant. NFC has become commonplace in smartphones during the early 2010s, and we had NFC tags, etc. And of course, for public transportation, also NFC was very popular. Then we have optical technologies like Li-Fi, Cisco's 40 gigabit bidirectional optical technology and all that, BiDi and so on. So it could be optical, it could be NFC, it could be RFID. Okay, so different technologies. All right, wireless or with optical or with wired. Let's go to the next slide, please. So optical tags and quick response codes, basically this is used for low cost tagging. The phone cameras basically they decode the QR code using image processing techniques, and in reality the QR advertisement campaigns gives less turnout as users need to have another application to read the QR codes, etc., etc. But nevertheless, these were the technologies where the enablers for IoT. You had the Bluetooth low energy. Once again, please. We have the Bluetooth low energy. This is one of the latest. Yes, Amit, you're not very audible. Can you just speak out clearly, Amit? Yeah, Amit, I'm not able to get your point, but I'm proceeding further. Could anyone decipher what Amit is saying, please, so that I can reply to the question?
Hello, sir. You are not audible. Please turn on your mic. I have muted the participant, so your mic is also muted by me by mistake.
Yeah. So I hope that now I'm audible.
Yes, sir.
Okay. So yeah, so there are different technologies, as you can see. We are really not missed much. There are numerous technologies based on IoT. We have the low energy wireless IP networks, which we can use, or we could also use Zigbee, which is based on IEEE 802.15.4. So all these technologies are available for us for the IoT. So the number of technologies which are what we call as the enabling technologies for the IoT. IoT is a huge thing, and because that revolution has to be supported, we need to have different types of technology. So if you go to the next slide, we talk about Zigbee, then we talk about Z-Wave. Okay, so the different communication technologies which are necessary. Now, why is it that such a big role to be played in the from the communication sector? The answer is very simple. Communication poses a challenge to us because of the energy requirements for communication. We want the communication to be with low power, okay, because many of the end devices, they are battery operated. So just like I just showed you this wireless switch, Wi-Fi switch from Sonoff. There's also a Wi-Fi, there's also a wireless switch which is Zigbee based, right? So Zigbee switch would be consuming about 1/3 the switch which operates with Wi-Fi, and that's the reason there's a group which prefers Zigbee to Wi-Fi, okay, because the lower power means that the batteries will last longer. In fact, particularly for sensor-based devices, like supposing you would like to have door window sensors, or you would like to have a motion sensor. All these sensors, if they are battery operated, you can hide them very conveniently. For security purposes, we don't want any wires to be really drawn for feeding power to such devices. And if they are battery operated, then it's of course necessary that the batteries last for a longer duration of time, and that's possible if you have a bright technology like let's say the Zigbee technology instead of the Wi-Fi. Okay, so yeah, so let's move further. So Wi-Fi Direct basically is essentially the Wi-Fi for peer-to-peer communication. We have the home plug networking standard. We have the networking standard used for enabling IoT communication over CATV or type coaxial cable, okay, MoCA, and you have the Ethernet. Basically, you've heard of the Ethernet. That's basically general purpose networking standard to enable IoT communication over twisted pair, right? So
Excuse
lots
me.
of
Sorry to interrupt you,
technologies.
sir. Someone is
Yes.
asking to explain more about Z-Wave. Someone has raised
Z-Wave.
comment
Yeah,
to explain more about
yeah,
Z-Wave.
sure, sure. In fact, we can take much of this offline. I'll definitely put some time on that. But see, as I said, we are Z-Wave is okay. If you understood Zigbee, then it's nothing but an enhancement over Zigbee. You can say, or a deviation from Zigbee called Z-Wave, because you can see that Z is the common, the first layer alphabet Z. But because this is not a standard like Zigbee, you have Zigbee 3.0 protocol. I would not like to right now look at Z-Wave in a bigger way. But right now, as I said, you consider that to be very similar to the Zigbee technology. All right, so it's beyond the scope of this particular presentation right now, because we are not per se looking at many of these technologies of the IoT at this stage. We're just trying to identify that there are technologies which are low power, okay, and we want to identify such technologies and go ahead. That's why I gave you the instance of, say, in Zigbee, what happens is the consumption is about 1/3 of that of the Wi-Fi. All right, so we want to just restrict ourselves to these points at this stage. We will take further details about every technology if we have sessions separately for the enabling technologies for IoT. Okay, so that itself is a presentation on its own. So, but right now, since our presentation is on AMI, we will go to focus on NB-IoT, and for that, whatever background information is required, I'm just restricting myself to to that and channelizing your thought processes in this direction. So what I would like now is to go to the slide number 70, and in slide 70 we have we have 6LoWPAN. Okay, what is 6LoWPAN? Basically, it's a contorted acronym. It's an acronym basically, right? And combines the latest version of the Internet Protocol, IPv6, and low power wireless personal area networks, or LoWPAN. And this 6LoWPAN basically allows the smallest devices with limited processing ability to transmit information wirelessly using an internet protocol. And it's a competitor to ZigBee. So I took ZigBee a little bit earlier, but now we see another competitor, right? So 6LoWPAN basically is nothing but another wireless competitor to ZigBee. This concept was created because engineers felt like the smallest devices were being left out from the Internet of Things, and we would like all particular devices to be brought in to this big umbrella, what we call as IoT. So the 6LoWPAN basically can communicate with the 802.15.4 devices, as well as other type of devices on the IP network linked like Wi-Fi, and a bridge device can connect the two together. Okay, so for smart home lighting, thermostats, smart meters, etc., the 6LoWPAN became popular. So this is another technology which I wanted to sing. And ZigBee, if you all want to have details, this all there on the next slide. This slide, and we can take a look at that. But as I said, because of paucity of time, I'm going to skip this. This is an important slide because ZigBee's technology is important. The 6LoWPAN slide is important because it talks about both of this are competing for lower power. Okay, so we want those kind of technology, communication technologies, which stress on lower power. Okay, so then we can go to the next slide, which talks about BLE, or the Bluetooth 4.0. Okay, which is called BLE, stands for Bluetooth Low Energy, right? You can see that always there's a stress for that energy, right? So low energy, BLE means Bluetooth Low Energy, and it's the Bluetooth standard to 4.0. So this is also a wireless technology to send and receive data, and so the range is about 77 meters, etc. So fine, and that all that. So we have three different technologies which we looked at, which you would like to understand as competitive technologies for our communication needs. So if you want to conclude on this section on the competing technologies, so engineers want to know what to expect if they use. Okay, so let's go to the next slide. So there is an overlap. For example, DDS can serve and receive data from the cloud. MQTT can send. So they're talking about MQTT, DDS. I've skipped on some of the slides. So let's skip out this one also, so that we can go directly to the NB-IoT. That is slide number 74, please. Good. So we are in the main section right now, because our thrust was on advanced metering infrastructure, or AMI, and it is the technology which we are going to focus on right now is the technology which is NB-IoT. So in NB-IoT, we are going to talk about low power wide area network, or LPWAN radio technologies, and this low power wide area network is a radio wireless network designed to allow long range communication at a low bit rate. You just note this point. This low bit rate is quite important, and this low bit rate, among things, why is it so important is because we are interested in such devices such as sensors which are operated on batteries. The low power, basically low bit rate, it ranges from either 0.3 kilobits per second. So we're not talking about megabits even, we're just talking about kilobits. 0.3 kilobits per second to 50 kilobits per second. And intended to use distinguish the WP, or not WP, LP WAN, which is low power wide area network, from regular wireless WANs. Okay, so just to distinguish between the WAN, the regular WAN, we have used this suffix or prefix LP. LP stands for low power. So WAN basically carries more data, but this is at the cost of using more power. So that's the regular WAN, or wireless wide area network. But when you talk about LPWAN, we are only talking about or touching about those technologies where the power is of concern to us, and we want to lower down the power. This comes at the cost of lower bit rate. Okay, so but we're not worried about bit rate. Particularly in the smart metering sector, we're not so much at all concerned about bit rate. So in fact, I'll take you quickly to one slide, slide number 89, which gives a glimpse of the various LPWA applications. So that slide 89 will be able to give you pictorially how technology, various technologies are there, but we need to decide which technology is most appropriate for us. Okay, so this is the slide which talks about the different applications that we have with us. Okay, so now our objective is to see which application suits us best. So I would say, can you just try to identify where our smart metering is? You can see that it's at the very leftmost part of the slide, right? You can see it on the very left portion, because what is there? What is the x-axis? It's the speed. On the very left we have 20 kbps. On the right we have 350 kbps. So different LPWA applications. We're talking about latency. That means in the left side you can have batch communication, whereas on the right hand side we need to have real-time communication. Smart metering does not come under the category of real-time communication. Okay, so we don't worry so much about latency at all. We are not so much worried about speed also. We can work with something like 30 kbps speed. Okay, so smart metering actually comes at the very end. You might think that smart meter is something which is should be hogging a lot of data, but the challenge to make any metering project successful, we should make sure that we able to communicate with the lower speeds, so that power issues are addressed and be able to make a big project successful. So left side, what you're having is NB-IoT, two leading LPWA technologies. One is the NB-IoT, which is focused on very low data rates and is ideal for simpler static sensor applications, and particularly for smart meter, we have entered into this NB-IoT. And on the right hand side, we have LTEM, which is the highest bandwidth of any LPWA technology. This is ideal for fixed and mobile applications. All right, so we are comparing two different technologies in this particular slide. Would anyone like to understand about the other applications which are there? Please compare it with the other applications. You can see that smart grid occupies somewhere in between. Smart grid occupies place around 100 kbps or so. All right, so that's the appropriate point at the smart grid, because smart grid essentially has more information content than just what you are having in the smart metering level at the nodes, the consumer nodes. So the consumer nodes, you need to have something which is very low power and able to communicate at very low bit rates. Okay, the objective is to collect information, meter reading from each of the consumers and centralize them. So that's the role of these smart meters. So if you have any questions on this, because this actually speaks volumes about the how technology plays such a big important role in all of this. So would anyone like to comment on this particular slide?
Hello, sir. Ketul Patel again.
Yeah. Yes.
Smart grid, because their execution, if execution is needed, that is, commands are to be given and execution is to be done, then speed will be higher, or then also this speed would be sufficing. Even in the case of executions sent through network execution signals.
Yes. Yeah. Very good point. If you need to execute something, if you need to get information, send information, etc., you always like to have speed. In fact, that's the reason on one side there was a drive to get more and more processing power. Why did we go from 8-bit and 16-bit to 32 bits? The idea was that ARM controllers are far more powerful than the 8-bit counterparts, okay, which were there in the yesteryears. So definitely there is always a liking for speed and power. We would like to have more power at the processing level, also at the communication level. We need to like to have more speed also. But just having a liking for it, it doesn't make a project successful. To make a project successful, we need to meet challenges. Why was the challenge not met successfully, with the earlier technologies? Because they were consuming far more power. Because when you talk about consuming more power, that means many things don't work out. You need to, at every place, you need to make sure that you are equipped for providing that kind of power. Second is you need to be equipped for handling that much amount of information. If you imagine every meter, providing, megabytes and gigabytes of, say, information, and you want to process that from that end nodes, is it feasible? That sheer volume of traffic, which comes from each of these meters, you have to ultimately convert your, data to information, right? And converting in data to information, which, or knowledge, essentially means that you have to process it. Just taking the data is not enough. That data has to be taken, some meaningful output has to be generated out of it. To generate that meaningful output, you need to have so much of processing power. Where are you going to do that processing? Are you going to do that at the consumer metering points? Are you going to do that at some intermediate points, or are you going to do it at the at the substation point? So all that decision has to be taken and resolved. So it is important that technology has to be looked, as a whole. You cannot just, focus on just the smart meter per se, nor can you focus on the technology that you're going to use at the central office or the substation. You have to look at it as the whole network. The whole network has to become smart.
Yes.
And that is why it is important that we need to focus on certain concepts which makes IoT made it feasible. So the reason smart metering is now borrowing from IoT is because IoT went ahead, in the whole step that, actually the need was most pressing in the power sector, our electrical power sector. Okay, but somehow we never had those technologies at our fingertips. Those technologies were available with our communication engineer counterparts. So they made giant steps because their focus was not energy metering. Their focus was on all the other devices. IoT means that they're looking at making every device smart. Just imagine a consumer is just having 1 meter in his house, let's say. Okay, but he has, let's say, 500 smart devices inside his house. So that's a far bigger figure than that 1 meter, isn't it? IoT addresses all these 500 devices inside the house, plus this small 1 meter, which is located just at the threshold, that is at the at the, I would say, near the door of the house. All right, so at the incoming point, you are having a meter plus all these other devices. All of them come under the IoT sector. So that is why this narrowband IoT assumes that importance today. Okay, so narrowband IoT, particularly for smart meters, because, and the good part is, smart meters does not need information to be passed to and fro from it, at a very fast rate. You have all the time in your life. It's just like, I keep telling the students that even if you look at a AC signal, which is a 50 hertz signal, it is just like DC for us in in the electronic sector. That means if any electronic engineering student is looking at electrical signals, it's just like DC for him, because it's 50 hertz. 50 hertz is practically nothing, right? We are talking about megahertz frequencies, operations, and processing power. So 50 hertz is very easily handled by a processor which works with megahertz clock. So that is the importance of communication technology, and that's why communication technology has been able to absorb smart metering within its stride, and it has located smart meter at an appropriate place, which was necessary to make its huge network. See, all other network, has been through the IoT thing itself. Smart metering was considered to be a separate, metering project and a smart grid project, different from the IoT project once upon a time. But now everyone has understood that why keep it separate? Why can't you bring it, tag it along with the other IoT devices and make it part of that, right? Of course, security and other things assume a critical role, but so also other IoT devices, there also security plays a very important role. So whatever features or requirements are set for the regular IoT devices, we can consider the same for the smart meters too. I hope that has answered your point.
Yes, sir.
So that's why it's so interesting. This the topic was just AMI, but again the term, as I said, AMI was coined 2 decades back. Okay, and that time AMI or advanced metering infrastructure was considered to be okay, or a newfangled thing compared to AMR or automatic meter reading was what was there, which was much before or prior to AMI. But today AMI is something which we don't use. We don't use that terminology anymore, because once you say for particularly right now, if I say NB-IoT, it assumes that NB-IoT means AMI. Okay, so it is the new terminology, and everyone has NB-IoT on their lips and not AMI anymore. So, but both mean the same thing, of course. But as I said, we are very much talking about a technology, a specific technology when you talk about NB-IoT. When you talk about AMI, we are talking in more general terms, about advanced metering infrastructure. So that could encompass anything, depending on what technologies were there in use 10 years back or 15 years back too. They were also AMI. Okay, that's why I said other countries had moved ahead with AMI, but India did not move ahead. And thanks to that, at least today we are going to have an AMI using the latest technology, which is NB-IoT. And all our, Vodafone and say Reliance Jio and all these other, telecom partners are all there to help us out with that. So that's the wonderful good part about it, that electrical engineers need not focus on communication anymore. I'm offering you all this information about technology, but it's not just to get you all psyched about that. Oh, there's so much of things which I do not understand about this. You don't need to. You always, knowledge is something which you build in layers. What we have to need to understand is the top layer, the layer which is of importance to us as electrical engineers. Let all the hidden layers inside be handled by the engineers of Reliance Jio, by Vodafone and all these other companies who are interested in taking a share of the pie, because if they get involved in the communication aspects, of course they'll get some revenue too. You know that all of these telecom companies are in a difficult financial situation, so the electrical utilities can help bail them out. So it's a kind of a win-win situation where they have the technology but they don't have funds. Utilities have funds but don't want to get into those kind of technologies which are not relevant to electrical sector per se. So you can focus on your core, I'd say core knowledge of electrical engineering, and leave the communication part, communication technologies, to the communication engineers, such as Reliance Jio or Vodafone. Of course, there are other names. I'm just taking names because they came up thanks to the Tata, utility in Delhi. Okay, but otherwise, this is not a marketing talk. So anyway, so now let's move further. So yeah, so this whole presentation later, because I'm just seeing that the clock is really ticking fast, and it's almost like 12 o'clock right now. So, but what is important to understand is this whole presentation which I'm having right from slide number say 74 onwards, it talks about NB-IoT or narrowband Internet of Things, and I think I've done a little bit of justice to IoT. So understanding narrowband IoT will not be because it's just an extension of the IoT and talks about one particular technology in this NB-IoT, right? So that's it. So now let me just take you a couple more maybe pictorial slides, because once I put you onto the other slides, it becomes difficult to appreciate this technology. So let's go to 101, please. The slide number 101. So to make you all understand about, because we are talking about AMI and advanced metering infrastructure, when we talk about meters, we are only talking about electric meters, right? Because we are only interested in electrical energy, but the world does not consider it that way. In fact, all other countries, they have already combined electricity with water and gas. So when you talk about AMI is not essentially metering infrastructure for only electricity. It is for gas also, as well as for water. Now the interesting part is for the gas and water, the information content which is there is very nominal. In other words, for water, it's just like how many liters of water you are supplying, or gas also, how much cubic centimeter of gas are we discharging through the meter, right? So there's only one information content, not like electricity, where you are having power factor, we want to know the time of day usage, and blah blah blah. So many things are there when you talk about energy metering. So of course energy metering means a little bit more complex or more data oriented meter. So what people did was they went into water and gas metering initially when they did their trial projects with NB-IoT and wanted to see whether it becomes a success. So once that happened, it became a success. They included electricity meters also with that, and now all the meters are with NB-IoT. Okay, so that's how the technologies have been used. So this is just to give you a glimpse of how in history how these technologies were being implemented. All right, so we are comparing water and gas metering here, and yeah, 2 slides later, 103, we should be able to see the different types of electricity meters. So here we can see that we are having the on the left hand side a single phase ANSI type electric meter. We are having a single phase IEC type. So the different standards, right? The IEC standards and that's International Electrotechnical Commission is IEC. Okay, so that's a single phase IEC type electric meter, and then you have also on the right hand side the 3-phase IEC type electric meter. So single phase and 3-phase IEC meters, they look kind of alike. Of course, the number of terminals inside would differ based on whether it is single phase or 3-phase. You can see that the number of terminals are more, but those are for communication. So you don't get confused on why do you seeing so many terminals on the single phase meter. Okay, so and they are all featuring one particular company only. The source is from Tatung company. So there are many such meter manufacturers. So I'm just acknowledging that those images come from them, but not necessarily saying that those meters are better than their counterparts from other manufacturers. So let's move further. So any questions at this stage, please? One thing I would like to talk about also here is about DLMS, right? So we can go to the next slide, 104. Because at one period in time in our Indian landscape, we saw that electric utilities were specifying, okay, we need DLMS protocol, that means distribution line message specification protocol, DLMS protocol. So the electric meters, as you can just read these 3 bullet points here. These electric meters for utility, basically they are typically running very chatty DLMS protocol. So they were the protocol was very chatty, means that it was quite intensive as far as communication was requirement was concerned. It was not frugal with data. It had lots of it was very chatty. In quotes, is put written chatty to indicate that so much of and again below that you can see connection oriented communication. So there's a lot of connection oriented communication, etc., which was there with this DLMS. Okay, so the DLMS message at its lowest level of meter hardware known as a register. So this was what was specified by our electric utilities in India. Okay, so anytime you see a specification document coming from or coming with a tender by electric utilities, this was because there was a focus on what we really want. So smart meters means that we need to have DLMS and all that. You ask the electrical utility engineer what is exactly DLMS and how it will be of use to him. He says, no, I have no idea. Absolutely, it is something which has been given from the very top. They are supposed to include that in the specification sheet, and they have included that. Having little knowledge about the technology and using that makes it a dangerous thing also. A new technology does not necessarily mean that it is the appropriate technology. Right? There are numerous new technologies, so you need to have the ability to choose and select what is right for you. But DLMS was a specification. It was a protocol specification which was specified right from the top, that is from the Ministry of Power and CA, Central Electricity Authority, and others. So because of that, it stayed, and every utility started following that. But if you ask a layman, was smart metering a success in India? He will lift his eyebrows and say, why do you say that? Because he'll, the utility engineer says that we have implemented DLMS. He says, I don't know whether you implemented DLMS or not, but I don't see it smart. Neither does the meter reader see it that smart. So why are you really so eager about DLMS? Anyway, so here what we see now in this, that we have come to next stage or next era called NB-IoT, we find that DLMS is not really suited for scalable transmission over NB-IoT or any other wireless network. Okay, because of this connection-oriented type style of communication. So here, what you need to have is something which is for which TCP protocol would have been better. Okay, so in the first point, as it says, so high-level instructions such as read meter usage data may be deconstructed into 10, 20, or even more low-level DLMS messages. Okay, just imagine you have 10 to 20 low-level DLMS messages to read a high-level instruction such as read the meter usage data. So simply reading the meter usage data can be broken down into so many DLMS messages. That means you read register 22, read register 34, read register 27, and so on. Each one with a send and acknowledgement TCP protocol overhead. So we just imagine all those protocol overheads, how much chatty this kind of communication would be, which would be DLMS based. So on the next slide, I'm showing you, the pictorially So let's go to the next slide, please. Yeah, so here we can see the difference between TCP and UDP communication, where we can see that for TCP means transmission control protocol. Basically, it's one of the protocols of the internet protocol suite, and it's basically something which is connection oriented. So for DLMS kind of chatty connections, we need to have something like the TCP, which is connection oriented. So there's a connection between the client and the server, and that's to be established before the data can be sent. On the right hand side, what you see is the UDP. UDP is the user datagram protocol. It's a communication protocol that's primarily used for establishing low latency and loss tolerating connections between the applications, again on the same internet. But such a UDP or user datagram protocol basically speeds up transmissions by enabling transfer of data before an agreement is provided by the receiving party. So this is the two protocols that we are having over the internet right now. And if you go to the next slide or slide after that, we can just proceed to the next slide, please. Because I'd like to cut short the presentation. Yeah, so in TCP versus UDP communication, TCP is a connection oriented protocol, whereas UDP is a connection less protocol. All right, and as TCP provides error checking support, also guarantees delivery of data to the destination router, it makes it more reliable compared to the UDP. But you can see here, on the other hand, UDP is faster and more efficient than TCP. All right, so is it important to see that you guarantee that delivery of data? Or is it important that you make this particular communication faster and more efficient? So today, as it turns out, we find that speed and efficiency is more important requirement. And if you have that, if you find that there is an error in the delivery of data, you can always see that the message is transmitted once again. We go to the next slide, which talks about how the technologies have been implemented by these the manufacturers. So this is a electric meter communication board with NB-IoT module, which is having the CPU used for edge computing. So this is the basically now kind of a single chip solution which you get in the market. So this is by some Huawei technology, and they have come out with this kind of a chip. What they have done is, normally you need for NB-IoT also you need to have a SIM card, but nowadays I think you might be aware that every processor has a unique signature within it, or a unique stamp within it. So using that, the manufacturers have been able to make the chips self-sufficient. That means you don't even need a SIM card to identify which meter it is. So every chip which goes into every meter is distinctly different. It's just like having its own ID, distinct ID, different from others. All right, so you don't need to have any more SIM card, etc. So these days NB-IoT now has come to or matured to a stage where it simply you can put it onto the board. The board can be simply housed inside the meter. The meter can be sold in large numbers, and the whole technology made a success. So this is how this is the I would say the stage that technology has come to, right? So any questions, please? One last slide, I'll put a pictorial slide, slide 116. But I cannot get into details of that slide because it covers too many things, aspects of NB-IoT. But the block level, what I'm trying to show you is that how this technology, NB-IoT wireless, the role that it plays in making this whole concept meaningful thing. All right, so if you want to understand about this, we can go to the next slide. So this talks about the entire architecture. Okay, so if you are deeply interested in NB-IoT, you can go to the this section of the presentation and be able to understand about this. So in this diagram, basically what we have seen is the electric meter, which acts as a DLMS server. So because we want to have DLMS, people said that, okay, we have already introduced DLMS as a standard. So whatever is there, we cannot argue and say that, okay, we remove this or we chuck this out or chuck this in. So we are having the electric meter, which is working as a DLMS server. It provides the register level DLMS responses when queried by a DLMS client. That means you are having a kind of a client server kind of a concept, right? So the electric meter basically it puts the query in and gets the responses. Okay, so that means the meter communication board, which we just saw earlier, basically it has the ability to communicate with the client, which is also there, and the server, which is also there, and get those responses what is necessary. So that's basically response are nothing but the information that you are seeking. The meter communication board acts like a DLMS client and converts the DLMS messages into the appropriately formulated upper layer message, then compresses, encrypts, adds the channel coding. That means you have some kind of coding like the Reed-Solomon coding, and the result is a meter that can efficiently send upper level messages over low power wireless networks, such as the NB-IoT network, to the back office data center for processing. So you can see that now a lot more responsibility is taken by the meter communication board. All right, so the meter communication board essentially takes that information, right? You can read this particular second point once again. The meter communication board acts like a DLMS client. Okay, you have the DMS client and you have the DLMS server, right? So what does the server do? Basically, the electric meter, which acts as the DLMS server, it provides the register level DLMS responses. So we take this DLMS messages, convert them into the appropriately formulated upper layer message, compress them, encrypt them, add channel coding, and then send the upper level messages over the NB-IoT network to the back office data center for processing. So this is what is essentially done in this overall system architecture that we just saw in the previous slide. All right, so and if we are conversant with this, all that's happening as far as this communication technology is concerned, then we can say that yes, we have mastered NB-IoT, and we be able to get our entire country on this network. What we underestimate because of its low power nature, that it would not be able to succeed. In fact, it's this very low power nature that's going to make that a successful one. All right, and that's what Tata has shown in Delhi, that it definitely can be taken up and scaled up in large volumes. So on that note, I think I need to leave at least a few minutes for you all to deliberate and talk about this technology. So probably I could just leave it at that, and so we can go to slide 120 or 119. We can just take the last 2 slides out there, please. So until now, NB-IoT has not taken a major role in deployment of electric utility AMI. Okay, so basically this is a slide which talks about what was the situation in the year 2019, 2018, and so on. Every year, every month counts. Okay, the technology is so this thing now that every month counts. We were hoping to get to a stage where, as I told you, upgrade from gas meters and water meters to electric meters. So now NB-IoT has also swept into the electric metering sector. In fact, I had published this article on NB-IoT in Electrical India, I think in 2019, right? So in 2019, I spoke about it and I said that this is the technology which is going to be of the future, etc., and all that, which is India should take. And you know what? Tatas have already done it, right? They have already shown that it is a success. So what I'm trying to say is that if you have a vision and you pick up the right technology, it's very easy to make it a success. Instead, if you take something which is going to be painful and difficult, because good technologies they are always simple. Simple technologies can only succeed. If you have complicated technology, you cannot take it with the the sheer volumes that we're talking about. We said just a few slides back that in India we're talking about 250 million meters, and that's not a small quantum. It's a huge thing, right? And to see that all of that information we can retrieve and use effectively is definitely not child's play. So if you look at this thing now with these slides, these 2 slides, I can sum up like this: that NB-IoT has not taken a major position in deployment of electric utility AMI so far, right? But today that's not the case. This slide is 1 year old or 2 years old, but in these 2 years, this statement has changed. Okay, so now it has taken a major position for deployment. In fact, not only in our country, in other countries, it's already being taken in a huge case. But the point is, in other countries, they already have AMI. All right, so it's just a change of technology to make it better. In our case, we are going from nothing to something. So the need is very drastically felt in our country. Okay, so we have right now we do it or do or die kind of thing. Okay, we have to go in for something, and at that stage, NB-IoT has come as a boon to us, because this is the AMI that will really survive. So to a large degree, this is due to the misunderstanding in some of the key architectural issues described above, especially the need for edge computing to convert low-layer DLMS messaging to upper-layer messaging, and the need to use best effort constraint application protocol, that is the UDP, rather than the TCP, right? So the need for using UDP instead of TCP, there was always, there was a difference of opinion, and that took time. People were always adamant about DLMS, so that took time. But now, when you have a will, there is always a way. So that way to convert this low-layer DLMS messages, converting them, the need for edge computing, that means you have that computing done on the edge, right, and pass on the information to the upper layers for this UDP based communication or UDP protocol rather than TCP. All that having been accepted today, now everything has been ironed out. All the issues which were there earlier, they have been ironed out, and we are getting the technology what we really require. So if you move to the next slide, I would put this as the last slide here. So the future of NB-IoT is quite bright, since 2G and 3G networks are being phased out, and a replacement will be required for cellular IoT portion of the electric utility grid. So around 5% of the connections. As AMI becomes more ubiquitously rolled out, ubiquitously means that it's there, omnipresent, everywhere. It's going to be there everywhere. Okay, we don't have to talk about it. Here we have AMI and there we don't have AMI. We are going to have it rolled out in such a way that every house has AMI, right? So, or every house is a part of AMI, I would say. So increasing the coverage from 85%, 90%, 95%, 99% becomes exponentially more difficult with traditional first generation AMI communication networks such as PLC or RF mesh. So those countries which had worked out, their first generation AMI. So here you can see this, this particular slide is not for our country, it's for those countries where they already got AMI implemented using PLC. PLC means power line communication. All right, so you just imagine that they still have technologies which are based on communication which is done over the power line. So power line communication technology is also there. But the interesting part is that they have been using AMI for the past 20 years, right? Whereas India has not done even the PLC. We don't have PLC, we don't have RF mesh, we have nothing, we don't have anything. All right. So we are coming from that stage. So in our case, it's going from 1% to 99%, not 85% to 99%. All right. So NB-IoT offers a low-cost, efficient way to provide gap filling and hard-to-reach meter connectivity. So something which was a big challenge, has been achieved, and it has come like a boon to India. So India gets the benefit of this because we were late to start on the smart grid front, late to start with the smart metering deployment and rollouts. So now these rollouts are taking place. Tata has taken the lead. Now Uttar Pradesh and all other states, which had earlier taken the lead in smart metering, they will continue with the smart meters of this technology, which is the NB-IoT. So on that note, I will, call it the end of the presentation. Probably there's one slide, it's not like slide number 122 after that. That means after conclusion slide. Just talking about what really IoT means, so what IoT really means. So if you just press a couple of times, you'll be able to see what this pyramid means. So the bullet points should pop up if you click, please. Yeah, so IoT is a big place. It's a room for many protocols. So you need to choose one for your application carefully and without prejudice. Okay, so there are so many protocols available out there when you talk about IoT. When you talk about AMI is part of this IoT. And for AMI, we felt today that NB-IoT is the right place to get into. That's the protocol that we need to latch on to. So the challenge is to seamlessly communicate between message-centric systems and data-centric systems. So we need to have that communication working from data-centric to message-centric. And that's why all that thing has been ironed out. Those challenges have been ironed out. And this represents the new revolution where you share things, the experience, or things basically share experiences with other things. You can see here there are no human beings involved. In other words, we can go over to the beach and relax on the beach, and we let the machines do all the rest. So smart metering, AMI, all these things are notions and concepts, not for us. It is for the machines. All right. So we are going to be out of it. We don't want to become slaves, or we don't want to get enslaved to the AMI program, okay, or the NB-IoT program. We want the machines to take over from us and do all these activities on their own. So that is the beauty of the IoT revolution. That's why I call it a revolution, because we are not seeing it. We can only imagine the revolution, because none of us here in our limited ways in India have experienced it to the fullest. Okay, so that's why we need to read about, because many people like to dream, and many have dreamt about what IoT means for them. Who have dreamt? All the big companies, okay, whether it's General Electric, Cisco, I give you these names, they all have talked about what IoT means for them, and they are talking about what would happen in the year, say, 2025. All right, so we also need to work out our roadmap and see where we would like to be placed in that period. So on that note, thank you one and all for the patient listening. I know that this is going to be a bit tough because it's so much information centered, and information which is not part of core electrical engineering. That's going to be far difficult for me to really convey my points out to you. But even then, I've just tried in my limited way to express this the views which I have in a kind of an interesting way. I hope that you'll be able to get at least probably 50 to 60% of whatever I try to communicate. The rest of it is all available on these slides. But as I said, this is only the first stepping stone. Once you get to the slides, please try to get through other sources, Google it out, find out details about it, and make it make it further. So my role was only to evoke that interest in you. I hope that I have done justice in that manner, because definitely this is nothing which can be it's not a topic that can be covered in 2 hours, right? But I have tried to at least see that something is done, because there should be a starting point. So this was just a starting point. So thank you again once and all. all of you who have been present here. Thank you. I'm ready for question answers. The floor is open for question answers. Can you please take this opportunity to pose the questions, please?
One of the questions in chat box is, can we do demand side optimization using smart meter?
Demand side optimization, yes. In fact, the Nandesiri experiment which we did was was a demand side management concept itself, because when we told the industries in Nandesiri that they should go for smart lighting, they raised their eyebrows and said, what's going to happen with those smart lighting, right? If I'm going to improve my power factor, am I going to get any benefit out of it? So demand side management means that you should show that the users or the place where the demand is, that's the consumers, they are able to take up the revolution from their side and make it work. They can only drive a revolution if they can see some interest in it, or they can see some incentive in it. And Nandesiri experiment, exactly that's what we try to show, that by using these dimmable LED lamps and fluorescent lamps. Those days it was fluorescent lamps earlier, then it became dimmable LED lamps, but we went into this dimmable bathtub characteristic kind of lamps, where street lights would dim in the middle of the night, and again it would brighten up. It would basically suit our pupil dilation and constriction. So that was what was worked out at Nandesiri. That's a demand side management thing, and that is a part of AMI. All right. So AMI's objective is to make the network efficient. That is why we are having AMI on the first place. And unless we achieve that, or we make that feasible, it's really, where is the revenue going to come from? The revenue is only going to come if we make the network more efficient. All right. How can you drive this NB-IoT revolution? You can drive it because whatever funds are required to be placed on these meters. Of course, these meters does not necessarily mean they're more expensive. Okay, please understand that NB-IoT or any other AMI-based meters need not be more expensive than the regular meters. In fact, the regular meters have so many of these tamper related things stuffed inside, which are very expensive. We don't need all those expensive tamper related things anymore, because all that intelligence now is with the network. We don't want intelligence at the node. Node intelligence is absolutely not, it's not going to suffice. It's not going to do the job. We want intelligence at the network level. And when you have intelligence at the network level, demand side management, or name it any other concept that you wish, all becomes feasible. All right, and that's what the beauty of when you talk at the network level. Okay, so smart network is what is it? So smart metering is the offset or offshoot of smart grids, right? So it's the subset of smart grids, and smart grids, is nothing but coming under the blanket of IoT. So this is how you have to look at it.
Sir, one of the questions from Chandani Shah: how will data be processed in smart metering?
How will the data get processed in smart metering, right? Very interesting question, because right now many of the utility engineers are bogged down just with information content. They are getting information from this MRI, that meter reading instrument, and they don't know how to process it, because the sheer volume, the nature of the meter data is such that compiled, or there's a log of so many days which has to be processed, and then you have to find out when exactly the tamper was taken place, how did it take place, blah 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 blah. So information is the most important thing, and that's why that's that last slide to you, where I showed you that the pyramid. What does that pyramid actually signify? That pyramid actually signifies, right, the one which one, the slide number 122. Yeah, so just can we get to that slide, please? Do we have that in front of us? Basically, at the top of the pyramid, you have wisdom, then you have knowledge, you have information, and you have data. If you are going to consider the base of the pyramid, the base of the pyramid is always going to be very wide, and that's the data. Right now, what the utilities are doing is they are processing data. So that data, when you are processing, of course, it's not going to be manageable. It's something which is not possible to manage all that information. And that is why smart metering project has been a failure for so many years in India. Because whatever trials they have tried out, those trials itself generated so much of information, that information which could not be processed. It was practically impossible, it was humanly impossible to process that much data manually, right? So far, the utility engineers were trying to do that and they failed. But if you go up the pyramid, then you go from the data, you go to the information, from information you go up to the knowledge and you get to wisdom. So when you are in the knowledge and wisdom sectors, you can see that we are at the tip of the pyramid. Here it's very easy to analyze. When you come into this knowledge point, you already have that information that so and so consumer uh, is pilfering energy, right? So you know that you are not done the processing. The processing is done by the system. It's the machines which are talking with each other. You are not doing the processing at all. You have been only fed the knowledge which comes out of that, the extracted information content which is of use to you. So that information is what is important for you as a utility engineer, and you can take a squad with you and go to the consumer premises, carry out a raid, and show bear that such and such tamper is taking place there. So all the evidence would be there, and the